Test the coil insulation visually. If it is okay, then switch on the furnace and run on maximum voltage for a few minutes. If a portion of the coil grout has been repaired, it should be dried well with an air heater or gas torch below 300 degrees centigrade before testing the coil insulation. At this stage, in earlier lining practice, asbestos sheets were used as a protection for the coil. However, the use of asbestos has been discontinued for environmental and for reasons of health. All use of asbestos should thus be avoided because of the following disadvantages of asbestos. Dangerous to health. Time-consuming installation. Additional cost of material. Shorter lining life as cooling effect will be reduced. Less security as the lining will be sintered through. More frequent coil problems as sintered lining will lift the coils upwards. More difficult breaking out of the lining as the lining has no powder layer. The next operation is ramming of the bottom. Provide the workers with face masks to prevent fine silica particles being inhaled by the workers. These are the ramming tools recommended for use in manual ramming of the furnace lining. Check the fork rammers. Ensure that the rammer prongs are sharp, of correct dimensions and well placed. Blunt and worn tools are the commonest cause for poor compaction.
I have seen different types of ramming tools being used in different foundries. Are there any guidelines for the design of the tools?
Yeah, first thing is ramming tools. Basically, it does a job of de-airing of the ramming mass. So you remove the air and the material gets compacted. That is the purpose of ramming tool. But when you are using a mechanical vibrator, the shape and size of ramming tool is not so important. So I will not comment on the ramming tool which are being used along with the vibrator because it's not so important. But when you are doing total lining with manual ramming, then the shape and size of ramming tool is very important. The guideline on design of ramming tool is, first thing is that the taper portion what we provide on the spike should be of more length. I have seen people using 20 mm diameter and taper is only 10 mm or 20 mm. But you can have almost 2-inch taper when the rod is big. So as per rod size, the taper length will reduce or increase. If diameter of the rod is more, the taper portion can be more. If diameter of rod is smaller, the taper portion will be less. And whatever taper portion height is there, we can have double the height of the straight portion. So that is a guideline. Don't make straight portion too long or too short. And the gap between two spikes should be as good as the diameter of the spike. So these are the guidelines. Based on this, we can design our own ramming tools. And if thickness is more, we can have 2 lines of the ramming tools put in a zigzag way. Or if thickness is still more, for 15 ton, 10 ton furnace, we can have 3 rows of the ramming tools, 3 lines of the ramming tools. So this gives you the better compaction in a lesser time.
Carefully place a 100 to 150 mm layer of the prepared ramming mix on the furnace bottom with buckets lowered to the furnace bottom. It is recommended to use ramming mass without boric acid for 50% of the height of the lower portion of the furnace bottom. This avoids total sintering of the furnace bottom and reduces the possibility of metal leakage from the bottom. Do not drop the ramming mix from height, otherwise fines and binder will fly out. Preferably use a funnel to place the ramming mix in deep places. After leveling off the ramming mix with the fork rammer, ram the bottom lining at the rate of about 40 man-minutes per square meter. This allows entrapped air to escape and finer particles settle into the spaces between larger ones to give a compact lining. Add further ramming mix in 50 to 60 mm layers and fork ram again. The length of the fork prong should be 10 mm more than the height of the layer of loose sand added. There is always a density gradient in a rammed mix, looser at the top and tighter at the bottom. So spend some more time on the upper layers than on the lower ones. You will feel that the penetration becomes harder as the compaction progresses. Compaction time versus height of ramming mass layer. 1-inch layer with 10 minutes compaction time will give better compaction than 6-inch layer with 60 minutes of compaction time. When you have come up to 25 to 50 mm above the required thickness of the bottom, ram with flat rammer a little longer than before, say 50 man-minutes per square meter of rammed surface. Stop ramming when you hear a booming sound. Further ramming will cause dust to fly. Scrape back the excess material to the required height. If the ramming has been done properly, scraping will not be easy. After scraping, ram lightly with the flat rammer to achieve a spirit level surface. Keep the mix to use for filling gaps. Complete the bottom lining operation at one stretch. If this is not possible, then cover the rammed bottom with plastic sheet and then cloth or gunny bags if left overnight to prevent condensation. Also, cover the furnace with a sheet metal cover plate. Monitor weight of ramming mass consumed for the bottom. Side lining. Now place the former in position. If the former is being positioned with the hoist, check with the plumb line to make sure it hangs truly vertical before lowering. Tall formers accurately centered at the top may not be well centered near the bottom unless they are dead vertical. If the coils are eccentric, lining will not be of uniform thickness. That is, it will be thinner on one side and thicker on the other. Check vertically again with plumb line after the former rests on the bottom. Hold the former firmly, centered with at least 3 wooden wedges entering the length of the former, not less than 150 mm and preferably 120 degrees apart. Do not remove the wedges until 3/4 of the crucible wall has been rammed. Start ramming of the tapered portion of the former if there is a tapered former in use. After the tapered bottom wall is rammed, adding ramming mix through the funnel in 40 mm thick layers and ram for about 5 minutes with 4 men. Most of the compaction takes place in the first few minutes only. Brief ramming of thinner layers is more effective than prolonged ramming of thinner layers. A separate mix for the top layer is not necessary. Most of the compaction takes place in the first few minutes only. Brief ramming of thinner layers is more effective than prolonged ramming of thinner layers. you will hear a different sound when compaction has taken place, to which you will get accustomed. Any further ramming will not only waste time, but also generate dust. A separate mix for the top layer is not necessary. Ramming with mechanical devices. Dry monolithics can also be compacted by vibration using mechanical or pneumatic vibrators. Most effective are those which vibrate a bottom plate or the former itself to effect compaction. You will now see a cross vibrator in use. Bottom lining using mechanical devices. Fill the ramming mass into the bottom of the furnace to a height of 15% above the required thickness. De-air the ramming mass with a spade-shaped tool. Level and cover with a 20 mm steel plate to which the pneumatic vibrator is bolted. The plate diameter should be 60 mm less than the inner diameter of the cemented lining. Switch on air to full volume for a moment. Then reduce air till a distant knocking is heard and felt through the furnace platform. This is the resonant frequency depending on the plate weight, which gives the most effective compaction. This occurs very quickly, within a couple of minutes. Further vibration can actually loosen the lining again. Run for 6 to 8 minutes at the optimum vibration frequency. Avoid vibrating for more than 14 minutes maximum. Steady pressure of 100 pounds per square inch is required. Other load of the compressor is to be isolated. Check compaction manually with the fork tool. Wait for 2 minutes for the vacuum between the plate and the ram layer to subside. And then remove the bottom plate and scrape off 10 to 20 mm of loose mix to a smooth horizontal surface. Check with the spirit level. After weighing the scraped off material, keep a record of net weight of ramming mix packed into a given height in order to calculate packed bulk density. Higher the density, better is the lining life.
Some foundries are reported to be using reusable formers. What are the advantages with this former?
Reusable former and removable former both are the same things. As name said, they are used again and again for years together and they are not melted out in the furnace. That's why it is called as a removable former. Some precautions are to be taken while using this removable former, which are critical but not difficult. One is that it has to have some taper for removal of the former. And second thing is that it is to be wrapped with a corrugated paper of maybe 1.5 or 2 mm thickness. Then thirdly, I will advise to use a mechanical vibrator system with this removable former so that the compaction is done by the machine and not by the manual tools. If you use manual tools, there are chances of paper being torn out and removal former taking out becomes difficult. Another precaution is that you have to have a little thicker former so that it doesn't get distorted during sintering. With this precaution, anyone can use this removal former.
Lower the former as close to the furnace platform as possible before sliding away the sheet metal cover and lower the former into the furnace. Just before the former rests on the ram bottom, center it as accurately as possible. Avoid moving it about too much or it will disturb the bottom ramming. Check vertically again with plumb line after the former rests on the bottom. Hold the former firmly, centered with at least 3 wooden wedges entering the length of the former, not less than 150 mm and preferably 120 degrees apart. Do not remove the wedges until 3/4 of the crucible wall has been rammed. You are now ready to ram the side walls. Roughen the ram surface between the former and the side wall of the furnace. Add ramming mass mix in layers of 30 to 40 mm. A filling funnel is a must for this operation. Do not drop the ramming mix down the annular space. Otherwise, segregation may occur at critical corners. Use a funnel cone about 350 mm diameter and height, which is as long as the depth of the crucible, and with 60 to 80 mm diameter stem. Roughen the refractory bottom. Using a funnel, fill the ramming mix between walls and former all the way to the top, with occasional light hand ramming to place it well. Remove the pneumatic vibrator from the bottom plate and fit into this on the cross the 4 wooden battens along the length all at a time. The vibrator should be just below the halfway height of the former. Wooden battens should not enter the bottom taper area. Fill up the entire ramming mass using a funnel up to the top of the furnace. Use the fork rammers lightly during filling of the ramming mass. Start the vibrator with full air pressure, then back off till knocking vibration is achieved. This is as done before for optimum frequency. Check the vibrations of the former by vibrometer. It should be 4,000 to 5,000 vibrations per minute. Use a flat runner to finish the top of lining. The lining will show permanent linear expansion and rise above the level of the platform after some heats. If this interferes with closing of the furnace cover, do not ram quite to the top, but short of the top by about 30 to 40 millimeters. Shape the spout using the scraped out material. Paint with a sodium silicate graphite slurry for added strength and slag repellent. Sintering. If the ram lining is not being sintered immediately, cover the top surface with cloth and then plastic sheeting. Put the furnace cover in place and seal the edges with fire clay to keep out moisture.
Are there any guidelines for adopting any particular sintering cycle?
Yeah, there are guidelines for sintering of furnace, and if you use these guidelines, you will be more comfortable in lining and life can be better. See, I will split up furnaces in three categories: smaller size, medium size and bigger size. And the sintering cycle or rate of heating depends on the thickness of the lining. You have more the thickness, the sintering time is more. If you are thinner the thickness of lining, you have shorter sintering cycle. And the rate of heating for sintering recommended is 50 degrees for very big furnace, 50 degrees per hour for very big furnace, 100 degrees for medium size of furnace, and 150 degrees for smaller size of furnace. And sintering has to be done always with the scrap full filled in the furnace, and then sintering is to be started. Never do sintering with a small quantity of scrap inside the furnace.
The purpose of drying before sintering is to remove the moisture gradually and evenly from both the ramming mass as well as the water of crystallization from the boric acid binder, without it causing damage to the rammed monolith. Too fast drying at high temperature can cause cracks in the lining. During this drying process, the temperature should not exceed 80 degrees centigrade. Drying and preheating can be done with hot air, drying lamps, infrared heaters or electric heating coils, all of which give controlled heating. Charcoal and wood can flare into excessively hot flames and temporarily form steam or give rise to localized thermal stress. Coal dust briquettes may give a steadier glow. If the furnace is covered during dryout, leave a gap of 100 to 150 mm between the top of the furnace and cover to permit moisture-laden air to escape. Mains frequency furnaces should be filled to the top of coil level with starting blocks carefully centered. They should not touch the sides of the former and create hot spots. Medium and high frequency furnaces should be charged with clean, preferably short blasted material. The pieces should be as large as possible so that the power is effectively drawn. The starting blocks or scrap should be as clean as possible, free from rust or earth, slug or rust, so that the new lining is not immediately subjected to corrosive attack when the metal melts. It is recommended that smaller furnaces up to 6-ton capacity should be heated slowly up to 800 degrees centigrade till visibly red at the rate of 100 degrees centigrade per hour. Larger furnaces with thicker lining walls should be heated at 50 degrees centigrade per hour. After the metal has melted, it is heated to a temperature of 100 degrees higher than the working temperature or 1500 degrees centigrade, whichever is higher, and this temperature is maintained for 1 hour. The composition of the sintering heat is preferably of low carbon and high silicon in case of furnaces to be used for melting cast iron. Temperature above 1100 degrees centigrade can be monitored by pyrometers. These should be periodically checked and calibrated with a master instrument. Sintering with hot metal. For iron foundries, liquid metal from a cupola or another melting unit is often available for a sintering heat. This is desirable as the metal would be clean and free of slag. The liquid metal should, however, be added after the charge or former are red hot. Liquid metal should not be added to a cold furnace because the residual moisture and or water of crystallization in the boric acid could explode when the steam is formed. After a weekly shutdown or a cold start, liquid should never enter a furnace until it has been heated to 800 to 1000 degrees centigrade by other means. Otherwise, the liquid metal will penetrate the inevitable cooling cracks in the lining. before they have had time to expand and seal up again. For the same reason,